So we have studied about what are isobars and that the isobars have different physical and chemical properties. Now we will see some examples of isobars. Examples of isobars. So one example is argon with an atomic number of 18 and mass number 40, and calcium with atomic number 20 and mass number 40. So see, the mass number of argon and calcium are same, but they are two different elements. Calcium is an alkaline earth metal. Calcium is an alkaline earth metal and argon is a noble gas or inert gas. Okay, so one is metal, one is gas. So they have totally different physical and chemical properties, but their mass number are equal. So argon have number of protons 18, number of electrons 18, but the number of neutrons will be number of neutrons will be 22, and for calcium number of protons 20, electrons 20, and number of neutrons will also be 20. So their number of neutrons are different, number of protons and electrons are also different, just the mass is same. Another example is nitrogen with atomic number 7, mass number 14, and carbon with atomic number 6, mass number 14. We had said that there is one isotope of carbon with mass number 14. So in this case, nitrogen will have number of protons 7, number of electrons 7, and number of neutrons will be 14 minus 7, that is 7. And for carbon, number of protons 6, electrons 6, and number of neutron will be 8. It is only for this isotope of carbon. The other two isotopes, that is carbon 12 and carbon 13, are not isobars of nitrogen. Also nitrogen also has more isotope like nitrogen 15. This is also not an isobar of carbon. Only nitrogen 14 and carbon 14 are isobars. Okay. So the next one is isodiapheres. Isodiapheres. So what are isodiapheres? So they are atoms of different elements which have same difference between the number of neutrons and protons. Okay, so they are different elements, like if one is X with a mass of A and A1 and atomic number of Z1. Another element is Y, atomic number Z2, mass number A2. So they will have different atomic number, different mass number, number of protons, electrons and neutrons will all be different. Just the same thing will be the difference between number of proton and number of neutron, this magnitude. We are taking magnitude because not necessarily proton can also be greater than neutron, neutron can also be greater than proton. So, we will consider both the situations. So, the magnitude of difference is taken. Okay. So, what is the magnitude of difference? How can we write? Atomic number equal to number of neutrons plus number of protons. A equal to n plus what is the number of proton? Z, that is atomic number. So, n equal to A minus Z. So, for isodiaphers, the difference between N and P. So, what is the difference between N and P? It is A minus Z minus Z. So, A minus 2Z. This magnitude will be the same. Okay. So, some examples of isodiaphers we will see. The first one is fluorine with atomic number of 9 and mass number of 19, and sodium with atomic number 11 and mass number 23. So, for fluorine, the number of proton is 9, number of electron is 9 and number of neutron is 10. Okay. What is the difference between the number of neutron and the number of proton? That is A minus 2Z. If we calculate like this, then 19 minus 2 into 9, that is 19 minus 18 equal to 1. Also we can count from there, n minus p equal to 10 minus 9 equal to 1. And here for sodium, the number of proton is 11, number of electron is 11, neutron is 23 minus 11, that is 12. So, what is A minus 2Z? A minus 2Z is 23 minus 22 equal to 1. Also, n minus p equal to 12 minus 11, 1. So, the difference between neutron and proton is the same. Another example is boron and potassium. Okay, what is this? A is 11 minus 2 into 5. So, 11 minus 10, this is 1, and 39 minus 19 into 2, that is 39 minus 38, this is 1. So, these are isodiaphers. So, say actually fluorine, sodium, boron, potassium, all of these are isodiaphers because all of them have n minus p equal to 1, right. So, we have done isodiaphers. The next is isotones. Isotones. What are isotones? I think by now you can guess that isotones are atoms of different elements with same number of neutrons. Okay. Isotones are also called isoneutronic species. Isoneutronic species or isotonic species. So, examples of isotones. One is tritium, that is the isotope of hydrogen with a mass number of 3, and another is helium. Okay. So, tritium has number of protons and electron 1 and number of neutron is 2. Okay. And for helium, the number of proton and electron are 2 and the number of neutron is also 2. So, they have same number of neutrons. Therefore, tritium and helium are isotones. Let's see some more examples. Sulfur and potassium. Sulfur has an atomic number 16 and mass number 32, and potassium has atomic number 15 and mass number 31. So, in this case, what is the number of neutrons? Neutron is 32 minus 16 equal to 16, and for potassium, number of neutron is 31 minus 15, it is also 16. Another example is magnesium with atomic number 12 and mass number 24, and sodium with atomic number 11, mass number 23. So, magnesium has a number of neutron 24 minus 12, that is 12, and for sodium it is 23 minus 11, also 12. Okay. So, these are isotones, that is they have same number of neutrons. Now, we will discuss about isoelectrons and isosteres. Before we discuss isoelectrons and isosteres, one thing is isoelectronic species and isosteres are not necessarily just comparison between atoms. They can be molecules or ions also. So, we are still not studying about molecules and ions, but the reason I am saying this with all the other things are that so that no confusion occurs between isoelectrons, isosteres and other things that we have studied. Okay. So, what are isoelectronic species? Obviously, isoelectron have atoms or molecules with same number of electrons. Okay. We have said that electron number varies. So, for ions or for molecules, the number of electron can be same, like Na plus and Mg2 plus, that is sodium plus. Plus charge occurs when atoms donate one electron. Okay. So, sodium had an atomic number of 11, mass of 23. So, the number of electron was initially 11. For Na plus, one electron is donated, so a single positive charge. So, now the number of electron becomes 10, and for magnesium it initially had an atomic number of 12. Now it becomes 12 minus 2 electrons. So, it is also 10. So, they are isoelectronic species. Similarly, ammonia NH3, water H2O and methane CH4. They also have equal number of electrons. How? Nitrogen had 7 electrons and hydrogen has 1 electron. There are 3 hydrogens, so 3 electrons. So, the total is 10 electron. Okay, here hydrogen, 2 hydrogen have 2 into 1, 2 electrons, and oxygen has 8 electrons. So 10 electron. Here carbon has 6 electrons and 4 hydrogen have 4 electrons. So again 10 electrons. So the molecules of ammonia, water and methane are isoelectronic. They have 10 electrons each. Similar with BF3 and SO2. Boron has 5, fluorine has 9 into 3, that is 27. So 27 plus 5, it has 32 electrons. And for sulfur has 16, 2 oxygen have 8 into 2, that is 16, 16 plus 16, 32 electrons. So BF3 and SO2 are isoelectronic species. Same with sulfur 2 minus, S2 minus, Cl minus, that is the chloride ion, the sulfide ion, and argon. So sulfur had 16 electrons initially, right? Now 2 minus means it has accepted 2 more electrons. So 16 plus 2, therefore 18 electrons. Chlorine initially had 17 electrons. It minus 1 charge means it has accepted 1 electron. So 17 plus 1 becomes 18, and argon is a noble gas having 18 electrons. So these are isoelectronic species. You will study later in that, when you will study electronic configuration, that elements form ions because they try to attain the noble gas configuration. They try to attain the same number of electrons as a noble gas, as the nearest noble gas. So the nearest noble gas for both sulfur and chlorine is argon, which has 18 electrons. So sulfur and chlorine accept electrons to fulfill the 18 electrons. Sulfur needs 2 electrons to become 18 and chlorine needs 1 electron to become 18, so that they can attain the configuration of argon. So the last thing here is isosteres. Isosteres are molecules having same number of atoms and electrons. So the molecules of same number of atoms and electrons, like CO2 and N2O. We will study how the number of atoms and the number of electrons are same in isosteres. We will study this in details in the next lecture. Thank you.